Good morning, students. I am By-Basavaraja R C, your science teacher. Let Paris Higher Primary School, JCR Extension, Chitradurga. Welcome back to online classes. Today we will discuss about 9th standard, 2nd chapter, Is matter around us pure? Today we learned about the true solutions. A true solution is a homogeneous mixture of two or more non-reacting substances whose composition can be varied within the certain limits. A solution has a solvent and solute as its components. The components in the large amount is the solvent and the component in the lesser amount is the solute. For example, solution of salt in water, the solution of sugar in a water, the iodine in a water or soda water, etc. Next, the properties of true solutions. The true solutions is a homogeneous mixture. The particles cannot be seen by the naked eye. The solute, the particle cannot be separated by filtrations. The solute particles do not settle down and the solution is unstable. The particle do not scatter a beam of light the passing through it, and the path of light is not visible in. Next, the saturated solutions. A solution becomes saturated if the solute starts separate at the bottom of the container in which the solution is being prepared at a given temperature. Next one is, what is saturated solutions? Is a solution which cannot dissolve any more of a solute at a given temperature. Solubility of a substances is the amount of a solute the present in a saturated solutions of a substances. This is called a solubility. Next, unsaturated solutions is a solution which can dissolve some or more solute at a given temperature. Next, preparation of a saturated solutions. Take 50 ml of a water in a 2 beakers and add salt in 1 beaker with continuously stirring till no more salt dissolves in it. In similar, add sugar in other beakers with continuously stirring till no more sugar dissolves in it. We get saturated solutions of a salt and sugar. If the mixtures are heated, it dissolves some more of the solute. The solubility of different substances are different. The solubility of substances varies with temperature. The concentration of a solution. The concentration of a solution is the amount of solute present in given amount of the solvent or solutions. How to find it? The concentration of solutions. The concentration of solution is equal to amount of a solute divided by amount of solvent, or amount of solute is divided by amount of solutions. The mass, the percent. The concentration of a solutions can be expressed as mass by mass, the percentage, or as mass by volume percentage. Mass by volume percentage of a solution equal to the volume of solution into 100. Next one is colloidal solutions. A colloidal solution is a heterogeneous mixture of two or more substances. For example, mixture of starch in a water, the mixture of egg albumin in water, the milk or air containing dust and smoke, etc. And properties of colloidal solutions. The colloidal solution in a heterogeneous mixture. The particles cannot be seen by naked eye. The solute particles cannot be separated by filtrations. The solute particle do not settle down and the solution is stable. the particle in a colloidal solution the follow zigzag path, and the particles the scatter a beam of light the passing through it, and the path of light is visible in a solutions. Next one is Tyndall effect. When a beam of light is passed through a colloidal solutions, the colloidal particles scatter the beam of light, and the path of light becomes visible in the solutions. This effect is called as a Tyndall effect. Tyndall effect can be seen when light enters a room through a small hole due to the scattering of light by the dust and the smoke particles. This second image shows this concept. Next one is the Tyndall effect can be seen in a dense forest due to the scattering of light by water droplets in the mist. The third image shows. Next one is suspension. A suspension is a heterogeneous mixture of two or more substances. For example, solution of sand in a water, solution of chalk powder in a water, etc. The properties of a suspensions. The suspension is the heterogeneous mixtures. The particles can be seen by the naked eye. The solute particles can be separated by filtrations. The solute, the particles settle down and the solution is unstable. The particle the scatter a beam of light the passing through it, and the path of light is visible in a solutions. Next one is suspension. This image shows a suspension. The first one is the solute particle can be separated by filtration method. Second one, the solute particles settle down and the solution is unstable. And third one shows the solute particles the scattering of light. Next, the difference between the suspension, colloidal solutions and solutions. First one is properties. In particle size is in suspension 100 less than 100 nanometer. In colloidal solution 1 to 100 nanometer. In solution more than 100 nanometer. In filtration separations, in suspension method is possible, colloidal solution is not possible, and solution is not possible. In third property is the setting of particles. In suspension, the settle on their own. In colloidal solution, the settle on centrifugations. And third one is do not settle down. In fourth property, appearances. In suspension, opaque, and colloidal solution is transparent, and solution is transparent. In fifth property, Tyndall effect. In suspension, it shows a Tyndall effect. In colloidal solutions, it shows a Tyndall effect, and solutions do not show a Tyndall effect. In sixth one, in diffusion of particles. In suspension, do not occur diffusions. In colloidal solutions, the diffusions are very slowly. In solutions, the diffusion is rapidly. In seventh one is Brownian movement. The suspension is very may slowly. In colloidal solution, it occurs slowly. In solutions, the may or may not be shown. In eighth one properties, the nature. The suspension, it contains a heterogeneous nature, and colloidal solutions in heterogeneous nature. In solution contains a homogeneous nature. Thank you students. Today we will stop here.